Okay, let's look at an experiment where we have a limiting reagent problem with calculating the percent yield. So the first thing that you need to do is to write a balanced equation. So we have aluminum is combined with oxygen gas. So we'll write our equation. So aluminum plus oxygen gas, and that's going to make aluminum oxide, Al2O3. Okay, you'll need to balance the equation. So we'll put a 2 here, a 3 over here, and then that will give you 4 aluminums over here, 4 moles of aluminum. Okay, then the next thing that you would do is you'll have to set up two problems. Alright, so one of them will be for 0.89 grams of aluminum. And we're going to solve that for how many grams of aluminum oxide it makes. Okay, because we're asking for the percent yield of aluminum oxide. So we are starting off in grams, so first we change to moles. So 1 mole of aluminum, and that equals 27 grams of aluminum. Okay, then we're going to do the mole ratio from the equation. So remember to follow the principle of diagonality. So for every 4 moles of aluminum, we're going to get 2 moles of aluminum oxide. And then we're going to need to change the aluminum oxide to grams because they're telling us that if 1.2 grams of aluminum oxide are formed, so we're going to want to change it to grams. And so 1 mole of aluminum oxide, and then you do the molar mass of aluminum oxide, and it's about 102 grams of aluminum oxide. And if you do the math, you end up getting about 1.7 grams of aluminum oxide. So what that means is you have enough aluminum to make 1.7 grams of aluminum oxide. Now we're going to deal with the oxygen. So with oxygen we have about 0.40 liters of oxygen gas. Alright, and since we're doing it at standard temperature and pressure, we can use the 1 mole. For every 1 mole of O2, you would have 22.4 liters at STP. Okay, then we're going to do the mole ratio. For every 3 moles of O2 that reacts, you would get 2 moles of Al2O3. And then you change to grams. So for every 1 mole of Al2O3, you would have 102 grams again of your Al2O3. And so the answer to that problem is around 12 grams of Al2O3. Now this is a limiting reagent problem. So we did 2 problems with one with each reactant, solving for the same product. And what you'll find is that the smaller number is, in theory, how much you should get. So if this reaction occurred as written up here, in theory, if everything reacted 100%, we would end up getting around 1.7 grams of aluminum oxide. That is called your theoretical yield. Okay, the answer to a stoichiometry problem is your theoretical yield. Okay, so that's this 1.7 gram. Now, the problem is asking for the percent yield. So the percent yield is equal to the actual yield that you would get from a lab experiment, the actual yield divided by the theoretical yield times 100. And so if we want to calculate the percent yield for this problem, which I just call it percent y, that's going to equal the actual yield. So this, if you read this closely, it says if 1.2 grams of aluminum oxide are formed, so they're implying that that's formed in the lab, that's going to be our actual yield. So we'll take 1.2 grams We're going to divide that by the theoretical yield that we figured out from the stoichiometry problem, which is 1.7 grams, and we're going to multiply that times 100. And if we end up doing that, I believe that ends up being around 71%. Okay, so in review, the percent yield is equal to the actual yield, and that's what you get, that's like what you find in a lab experiment, divided by the theoretical yield. That's the answer to the stoichiometry problem, times 100. And so I did that, I got 71%. That's it.